Hi, my name is Leslie Shannon, and I'm with Nokia. I'm Nokia's head of trend scouting, new technology trend scouting. And the reason that I'm here is I want to talk to you about mobile networks and XR, both AR and VR. And so, because there's a lot of talk in our industry about how 5G in particular is going to be good for mobile networks, but especially with people, setting fire to 5G base stations over in Europe and trying to rip them off the poles and stuff because of rumors about things. I thought it was a good time to actually set the record straight about 5G. I also should set the record straight a bit about Nokia. We are a company with a terrible brand problem. Everybody knows us for the mobile phones that we don't make anymore. We sold that business to Microsoft almost 10 years ago, but we still do make the network equipment that the phone companies buy in order to actually put together networks. And we always have. That's a business to business market that we're very well known in, but less well known by the consumer people. Okay, there we go. So let me start off by telling you just a little bit about 5G in terms of spectrum, because this is something that doesn't get discussed very much, and there's a lot of misapprehension and misunderstandings about this in the market. So what I'm showing you right here are the different spectrum bands, and so going from 600 megahertz all the way up to 39 gigahertz that are being used currently for mobile telephony around the world. And as you can see, these different colors of shading in the columns, these are the different spectrum bands that have been allocated to the Gs, if you will. So 2G started off in just these two bands, the 800, around the 800 megahertz, and then 1800, 1900 megahertz. And then 3G kind of was in the 2G band, and also a little bit more. 4G had many more. Okay, the reason this is important is every country manages, they have their own regulatory history and they have their own set of how spectrum has been used over time. And so one phone company would really only get a spectrum allocation in one country in one of these bands. And over time that created problems. Like, for example, Ukraine, I don't think they ever got 3G, or at least they got it really late because the military was using that spectrum and they would move out of it. Anyway, each G technically tries to solve the technical problems of the G before. And so whereas each, 2G, 3G, 4G was in specific defined bands of spectrum, one of the things with 5G, to solve the problem of countries where that spectrum was not available, not being able to use it, 5G is actually available in all spectrum bands. That's why I've got this kind of light blue thing going across the bottom here. And in addition, it's available and where it's fully available is in these higher bands as well, on the right-hand side. And so what that means is when somebody says 5G, there's really many different flavors of 5G. 5G that's in the 600 megahertz range, and this is important, these really low megahertz range, these are long, low, slow waves that can travel for tens of miles and can actually penetrate through walls and things like that. So that's really good for rural coverage. Whereas something in the higher frequencies, that actually carries more bandwidth, but it doesn't go as far and it doesn't penetrate as far. And by the time you get to these, 26, 28, 39 gigahertz bands that are the new ones, that's called the millimeter wave bands for 5G, it's super high bandwidth, but it is so unable to penetrate things. It is line of sight only. A leaf on a tree will stop it. And for that matter, so will your skin. So this idea of 5G actually getting into your body and messing with your organs or causing coronavirus is pretty ridiculous, because the 5G is either in bands where we've already had 2G, 3G, 4G for the past 25, 30 years, or it's in these bands that are so high that it doesn't really go very far. Now, so that's, a little bit of public education there that we could all use at this point. Now, when we're talking about implementations for 4G and 5G, oh, and actually the column, these purple columns, that's the number of implementations per phone company around the world. Most of the ones in North America are actually down at the very low end. T-Mobile and Sprint have a lot of spectrum allocation there, or in the higher end, the millimeter wave. Verizon and AT&T have done a bunch of launches there. But the millimeter wave stuff, like I said, it's very for small, short distances, ideally inside on a factory floor. That's really where you would see those. So the kinds of 5G that we'd be looking at for something like some kind of XR implementation would probably be very similar to the 4G, 5G, or this 3.5, 3.8 gigahertz range, which is where most of the world is actually doing most of their launches. And the thing is that the spectrum, so even though they're using the same spectrums that these earlier G used, 5G is configured to actually use those spectrums much more efficiently so that you do get a much better bandwidth and a much better result and a much lower latency out of the same spectrum that the other Gs were using. So if there's anything unclear about all this, please wait for come back to the Q&A and ask me more questions. But having said that, now let's look a little bit about where we actually see XR fitting into this. Now, I want to clarify as well. Right now, Nokia, we're actually not doing anything in XR or VR, but we're building the networks that we know are going to be supporting this in the future, and that's where our interest is. So my role is to really help to understand everything that's going on in the XR and the VR world, so we can make sure that we and our phone company customers build the right networks to support everybody here. And so I see with great interest things like HTC's current project Proton, which is it's kind of a future vision of the blending of AR and VR, so that it either goes completely clear and you can see the world with maybe some MR mixed reality in there, or the same device actually goes opaque and does what's called pass-through video, where it's showing the real world, but it's a representation on it's a fully VR experience. It's just that you're seeing the real world around you in VR. And it's just much easier to actually integrate kind of mixed reality things into that situation. So that's a vision that we really see is quite powerful, and I love that HTC is pursuing this. And I think I really want to mention this because the network stuff I'm about to talk about, I'm going to talk about really the AR use case, which is really, but ultimately it will be the same as the VR use case. So. Okay, and so here's kind of HTC's vision of the future, where you would have glasses that would be see-through or go opaque, depending on how much of the reality you were having around you be altered. So, okay, so what does the network look like to support this kind of long-term vision? Well, today these triangles kind of stand for, these heavy, expensive end devices where the processing is either on the device or on a big, expensive laptop that you've got wired next to the device in terms of VR. But where we're really seeing the future going is actually the processing coming out of that end device. And so that makes the end devices lighter, cheaper, less likely to overheat. And then the analytics or the computing going into MEC there stands for Mobile Edge Compute. So some kind of a node not very far from the end user. I've got less than 50 milliseconds from user. And here we're actually limited by the speed of light, because the transmissions that are going through the optical fiber, actually 5G, really being the link between these two for mobility. And so you're not tied down with the cord. But, we are limited by the speed of light here, which is the best possible. And of course, 5G is going to be a little slower than that. But if you want to have the kind of latency and have the kind of immediate rendering so that you can actually have these augmented reality, mixed reality experiences, you physically have to have that processing. If it's in the network, if it's not on your device, and if it's not on not on your head device or not on, some kind of a phone or something, then it would have to be actually quite close to you in the networks, which means really looking at the computing happening in a phone company's network rather than one of the big web scale players like a Google or an Amazon, because they're not going to have data centers every 50 milliseconds worth of speed, kind of every 300 kilometers or so, but it's actually the phone companies that do have that distributed network. So we really do see, a strong potential role for the phone companies of the world in the future when it comes to actually providing the compute power that's necessary for these to become commercial. And so the path that we really see, and this is where the G's really matter, is that, right now we've got handheld AR, and that's 4G, works just fine. AR cloud is where we're first starting to actually get things happening and things processing, not just on the phone, but in the cloud as well. And this actually is where you need to start having a lot of upstream power and being able to send video from my device into the cloud and have it be modified somehow or understood somehow. And then something coming down to me that I see. And so that's actually where we start getting mixed reality. And so an example, just going back to 4G, an example that we see there, Pokemon Go, kind of augmented reality, kind of works just fine on 4G, no problem. But when we start getting into more of the cloud processing and actually doing mixed reality, that's where we start getting more of a Minecraft Earth experience. And I'll give you an example of that in just a second. But when you're talking about consumer AR glasses, it really has to be 5G. 4G is no longer good enough for this. And the reason is that 4G just does not have the power for the processing to be on another device and then to be fast enough and have enough bandwidth for it to actually match you as you move around and look around. And then cloud rendering, where we actually have, really the full on creation of another layer of information or visuals that's really kind of permanently there. Yeah, that you definitely need 5G for. And so the consumer AR glasses we're starting to see with 5G implementations. I'll talk about Kddi, an operator in Japan. And then the full on spatial internet is actually what we've got coming in the future. Now, so for Minecraft Earth, in case you haven't played this, it's out there in beta. Minecraft really hasn't made a whole lot of noise about it, but it's available in the App Store in most countries I've been to. And so, and it works a lot like Pokemon Go, is that you have to physically be somewhere. But when you actually get to these adventures, it then clicks over to your camera, and it does give you this mixed reality experience where it sets the Minecraft thing into your visual field, and then you can actually start digging, and in this case, oh no, spiders! And and actually interact with this, and it really is quite an immersive, full scale life-sized kind of thing. But even more important than this, you could build in it. And this is a clip from one of Microsoft's publicity videos. So the idea is that you can actually take and you can build in Minecraft, and then you can invite other people to see. And this is actually the idea of persistence, having persistence in that MR world. This is where we start actually getting the idea of different layers of reality that are visible to the people who have the key to be able to see it. This particular AR application. Now, right now, if you build something in Minecraft Earth, when you leave that session of the game, the thing that you built goes away. But this is really the first step towards being able to build things that will persist, that anybody can come along later and see and modify and interact with. And this, as you can imagine, this is going to be super rich stuff. Now, moving into the consumer headsets, for example, Kddi, as I mentioned, in Japan, they launched their 5G about 6 weeks ago. And one of the parts of their 5G launch is actually they're partnering with the Chinese glasses developer Nreal to create a 5G experience with their glasses. And so you can see they do have a tether, a cable tether to a 5G phone to actually help create this. The Kddi people have told me, though, and many other kinds of, augmented reality headset providers, the long-term goal is to actually put that processing in the network so that it doesn't need to have that clumsy cable, and you don't need to actually have a physical device with you in order for these classes to work. That is longer term. But the kinds of things that Kddi is already experimenting with, this is an example they had from a developer week back in September of last year. This is the Shibuya neighborhood of Tokyo. And so they just kind of threw a whole bunch of stuff in here just to kind of, all right, what can we do with this? So advertising on buildings, weather, all kinds of freaky stuff flying through the air. This is really kind of where they're hoping to go and where they're working on with their 5G. Maybe not everything at once, but definitely all all kinds of information and entertainment visible with your glasses, and ultimately without you needing to have a phone there as well. And, and this is very much in line with the kind of vision. This is aside from Magic Leap, the kind of spatial internet viewing kind of thing that we see is really the vision that we all share for the future here, or at least I share for the future. Now, but there's another element here that I want to cover in this. The title of this talk is that the mobile networks is mixed reality's best friend. Well, you know what the other best friend of MR, XR, AR, VR is? It's gaming. It's 5G cloud gaming, and I want to show you why. And it's because if you look at these are the global entertainment revenues for movies is in the middle. I kind of left them out there so you could guess for a little bit. Music is on the right and games is on the left. Gaming, the global gaming industry in 2018 pulled in $152 billion. It's this gigantic, 2.5 billion users. However, the gaming industry has a problem in that everybody who's going to ever have a gaming console probably already has one. So what they need to do is they need to actually now to reach the countries, specifically India, Indonesia, the Philippines. These are the countries that they're going for. The gaming console people need to actually take the processing out of the consoles and move them into the network so that they can make that cheap mobile phone be the thing that actually lets you enter into the gaming world. But the last leg has got to be fantastic, as Google Stadia found out when they launched in North America back in November and immediately got ragged all over by, in this case, Fortune magazine saying, the connection was terrible. It was, you would die during gameplay if your Wi-Fi, blipped out for a second. That's unacceptable. So the gaming community, also, the thing about gaming is that if you actually have, an Xbox that you're selling, to keep the price down, you can only have one GPU in it, one graphical processing unit. If you actually move the gaming into the network, again, connected with that fast last leg, you can actually have a stack of 40 GPUs. And now you can start doing things like ray tracing, which gives you just a much richer video experience in your gaming. And so you can see that the gaming is actually pioneering exactly the same structure in the network that the VR and AR need. And and the thing is that gaming already is gigantic and already has a ton of money attached to it. And gaming also is already creating alternate universes that people are used to spending time in. Marshmello had his concert last February in Fortnite that had 25 million people. Travis Scott had a show in April. There were 27 million who saw all the different instances of that screened. And the thing is that Fortnite discovered in between, it's like the Marshmello concert was just Marshmello on a stage. The Travis Scott one, they're like, wait a second, this is virtual. We can make anything happen. And so it became this totally psychedelic, trippy experience. And that's what the gaming community already is used to on their PCs. It is but one short step to leverage the gaming in the networks that's coming with the 5G cloud gaming, with the big money push from Xbox, from PlayStation, all of those gaming companies. They're going to create that network architecture that's going to be what we need for our MR. And so it's 5G cloud gaming is actually AR and VR's best friend, because that's going to drive the bandwidth, the latency, the powerful processing, and that new way of accessing these compelling, existing, immersive universes that people already love spending all of their time in. But most importantly, gaming is going to bring money to this whole industry. And this is going to be the groundwork for what we want to see coming in AR and VR. So I'm actually really excited. I hope you can tell that. And I hope you are too. So watch the network. Anything you can do to support 5G cloud gaming, do it, because we are just the next thing in the step. And so just want to close with this quote from Bill Gates. We always overestimate the change that will occur in the next 2 years and underestimate the change that will occur in the next 10. Don't let yourself be lulled into inaction. So anytime you're thinking, this all keeps going so slowly, I just want to remind you, in 2000 on 2G, this is what mobile data looked like. And only 7 years later, after 3G had been introduced and Apple figured out the best way to unlock it, this is what it looked like. And this changed everything. I firmly believe that, okay, 4G added video to this. 5G is going to be the thing that takes this all into the immersive technologies that all of us know and love. And so after you've heard what I had to say, I hope that you agree. And so we've got a great, great future ahead of us all. Thank you very much. Now, and actually, if you'd like to ask me any questions, please do. I will be in the Q&A room right after this presentation. Thanks for your time.
Thank you, Leslie, for great and definitely the most energetic presentation so far. you actually answered all the questions I could think of.
Oh, that's very good. That's very good.
And as often happens with interesting and very complete presentations, we actually need to move the Q&A to the chat box.
So that is no problem at all. Yes, because I think I spoke a little longer than I should have, but that is okay because I can answer whatever's going on in the chat. And if anybody wants to get in touch with me and continue talking, I'm always interested in hearing what other new companies are doing. And so just LinkedIn, Leslie Shannon, Nokia, that'll do it.
Okay. Thank you again, Leslie.
No, moi na kiitos.
Kiitos.